Hello everyone, welcome to the Makri Virtual. Hope you are doing good. Today I'm so sorry first of all for the delay in the class. I have some urgent work due to some emergency, so I'm so sorry for that first of all. Then I'm going to continue with your chapter number 1, that is starting with the module that is a procedure programming. So let's continue with the C language. First of all, let's take a quick recap what we have covered in the last class. In the last class we have started with the basics of the C language, what is a procedure language, how to start with the C language, this is the C language. I believe in this we have studied various reasons why why we study the C language, what is the benefit of studying the C language. This says, or these points says, C is very beneficial language, very common language, very basic language that is used for the other languages as well. Major parts of the popular operating system are also written in the C language. We have studied various advantages, like mobile devices is also using the same, or mobile devices are also made up of the C language, that is a program that is written for the mobile devices is also written in the C language. Next, you must have several professional 3D computer games that is also done, or that is also written in the C language. At times one is required to very closely interact with the hardware devices. Why? Since C provides several languages elements that makes this interaction feasible without compromising the performance. Then next is your getting started with C, that is start with the C. What is a C? What is a C language? Any language means any language when you talk about in terms of the English statement. One is alphabet, one is words, one is sentences, one is paragraph. Means first of all there are alphabets, then there are different words, then there are different sentences, then there are different paragraphs. In the same way, the steps in the learning the C is first of all learning the alphabet, digit, special symbols, constant, variable, then instructions, then program. It means collection of alphabets is a word, then collection of words is known as sentence, then collection of sentence is known as paragraph. In the same way, in C, first of all there is alphabets, then digits, special symbols, constant, variable, keywords. So these are the basics, or these are the steps how C will be used. We have studied about this. Then we have studied about the C character set, that is what is a C and why we are using the C. These are the C characteristics. First of all there is alphabets like AB till Z, small ab till Z, digits that start from 0 ending with the 9. These are the special symbols that is used, that is exclamation mark, @ hash. Then we have talked about the constant, variable and the keyword, that is how constant will be used, or what is a constant, what is a variable and what is a keyword. There is a difference between the constant, variable and the keyword. Constant are the symbols that is available, or that is used, or that is used for the calculation. Variable values vary from the time to time, that is if I store the variable value as 3, that it will change because it is known as the variable. Then we have studied about the C constraints, that is what are the types of C constraints that is available, that is divided into two parts, that is a primary constraint as well as the secondary constraint. These are the C constraint, one is primary, one is secondary. In primary there are three types, one is integer, one is real, one is character. In secondary there are few types like array, pointer, structure, union, enum. Then we also studied what are the rules that is used for constructing the integer constraint, that is what are the rules that is used for whenever we construct the integer constraint, that is there is an integer value, there is not a decimal value. Then these are the rules for constructing the real constraint. These are the rules that is available for constructing the real constraint, that is the fractional part and the integer exponential part. In exponential form of representation, the real constraint is represented in two parts. One is E, that is a exponent, one is a M, that is a mantissa. That is before E there is a mantissa part, there is a E, that is a exponent part. This is the exponent, this is a mantissa part. Then we have studied about the rules for constructing the character constraints also. These are the character constraints that is available, that can also be constructed, and different rules are available. Then we have talked about the C variable, that is what are the types of C variable. These are the rules for constructing the variable name. So we have studied about different tools that is available for studying the or constructing the variable name. So these are the rules that we follow. That is the most important. That is, a variable name is a combination of 1 to 31 alphabet. That is, it does not contain more than 31 alphabets. The first character must be an alphabet or an underscore. No commas will be used, no special symbol other than the underscore can be used in the variable name. Since the maximum allowable length is 31 character, an enormous number of variable name can be constructed using the above mentioned rule. Then we have talked about the C keywords. That is, what is a keyword, what is the use of keyword. That is a predefined keyword that is available in any C language. Then we have talked about the first C program, that is the most important program. We have studied how to use or how to calculate the simple interest, that is P into N into R divided by 100. Then we have talked about the printf, scanf, what is a printf and what is the role of scanf. Then we have talked about the compilation and the execution. That is, what is the difference between compilation and what is the execution. That is, what is compilation and what is execution. So whenever we convert any program, that is a high level program, into the binary terms, that is 0-1 terms, that is known as the compilation. And the execution is whenever we execute something that is performing the output, that is the execution. Then we have talked about the keys, that is Control F9 is used to compile, Alt F5 is used to view the output. Then we have talked about how to receive the input by using the scanf. This is a function that is used to receive the input. Then printf is used to print the message or output the message. Then this is a C instruction, that is a today's topic, that is what is the C instruction. So let's start with the today's topic. Again, I'm so sorry for the delay, but I'm going to start with the C instruction, that is a C instruction. Now that we have written a few programs, let us look at the instruction that will be used in the program. So let's take the instruction that will be used in a program. So these are the few instructions that is available for the C language. That is, these are the instructions that is available for the C language. There are three types of instruction that is available in C language. One is type declaration instruction, one is arithmetic instruction, and one is control instruction. So these are the three instructions that is available for the C language. So there are three kinds of C instruction that is available. One instruction is your type declaration instruction, one is your arithmetic instruction, and one is your control instruction. Now, what is the meaning of arithmetic instruction? What is the meaning of type declaration instruction? Now let's see. The purpose is given as below. One is type declaration instruction, that is used to declare the type of a variable used in a C program, like int, float, double. These are the type declaration instructions that is used for declaring the C. That is a type declaration instruction. This says that is used, or this is used to declare the type of a instruction. Then next is your arithmetic instruction. That is arithmetic instructions are also used. That is the arithmetic instruction. Next, that is used to perform the arithmetic operations. What are the arithmetic operations? Like plus, minus, divide, multiply. So these are the arithmetic operations that is used in the C language. Then next is your control instructions or the control statements that is used for controlling the sequence of the execution of various states. That is the instruction that is used for controlling. This says since the elementary C programs would usually contain only the type declaration, we would discuss only two instructions at this stage. The other types of instruction will be discussed in detail in the subsequent chapter. One is your type declaration instruction. This instruction is used to declare the type of a variable being used in a program. That is a type declaration instruction that is used to declare the variable. Type declaration instruction is written at the beginning of the main statement. So type declaration instruction is used by using the main function. So main function is used for the type declaration. These are the examples. That the type declaration instruction is written at the beginning of the main statement. One is int bash, that is a basic salary, then float rs gross salary, then char name code, that is two variables are declared. One is name, one is code. So these are the few instructions that is available for the type declaration. Then there are several subtle variation of this declaration. That is variation means versions of this declaration. That is while declaring this type of variable or type declaration variable, we can also initialize it as shown below. That is, we can also use the initialization part, that is assign the value of 10 to the I, 25 to the j. In the same way, float a equals to 1.5, b equals to 1.99 plus 2.4 into 1.44. These are the few points that is available or that is used whenever we use the type declaration function. The next point says the order in which we define the variable is sometimes important note. For example, this is same as this one. That is, if I use I first, then it's okay. If I use j first, then it's also okay. That is j equals to 25, I equals to 10. This is I, not j. However, float a equals to 1.5, b equals to 3.1 is all right. But if I use b equals to 3.1, a equals to 1.5, that is, it's not. Why? Because this is because we are trying to use the a even before defining it. That is, the a is not defined. This is not defined first of all, but I'm using this one. It is defined after. So this is the most important point, that first of all variable should be declared, then it should be used in any other expression. Next point says the following statement would not work. That is, this would not work. However, the following statement would work. This statement will work, but this statement will not work. That is, first of all declare the variable, that is a, b, c, d, then assigns the value, that is a equals to b, b equals to c, c equals to 10. That is, both the variables or three variables have a value, that is a 10. Once again, we are trying to use the b before defining it. That is, we are trying to use the b before defining the values. So these are the type instruction, that is a char, int, double, float, that is a type declaration statements or instructions. Next is your arithmetic instruction, that is plus, minus, divide, multiply. So these are the arithmetic instructions that is available, that is a plus, minus, divide and multiply. These are the examples. First of all, use the int ad, float kot, data, alpha, beta, gamma, then ad equals to 3200, kot equals to 0.056, then delta equals to, or data equals to alpha into beta divided by gamma plus 3.2 into 2 by 5. Here, these are the arithmetic operators. What are the arithmetic operators? That is plus, minus, divide, multiply. Equal to is the assignment operator. That is assignment operator that is used for the assignment. One is your, two are your integer operators or integer constants. That is 2.5 and 3200 are the integer constant. Then next are the real constant, that is 3.2 and the 0.0056. Next ad, that is the integer variable. Next, KOT, alpha, beta are the real variable that contains the float values. Then the variable and the constant together are known as the operand. It means these are the arithmetic operators. This is also operator, and these are the operands. So this is the operand. These are the operands. This says that are operated upon the arithmetic operator. That is, operands are operated by the arithmetic operators, and the result is assigned using the assignment operator to the variable on the left hand side. A C arithmetic statement could be of three types. That is, C arithmetic or the C arithmetic statement can be of three types. One is integer mode, one is real mode, one is mixed mode. That is, three types of variable are used, or three types of arithmetic statements are used. That is the integer statement, integer mode arithmetic, real mode arithmetic, and the mixed mode arithmetic statement. This is an arithmetic statement in which all the operands are either integer or the integer constant. That is, either they are integer variable or either they are integer constant. Then real mode, that is in which all the operands are either real constant or either real variables. Then mixed mode, that is some of the operands are integer and some of the operands are real. That is, there are three types, or there are three types of varieties. One is totally integer mode, one is real mode, one is a combination of integer and the real. This is a combination of the mixed mode, that is the arithmetic real and the integer mode. Though arithmetic instruction looks simple to use, one commits mistake in writing them. That is, though it is very easy to look up, but it is very tricky to use them. Then next point says, what are the points that could be carefully used? That is, C allows only one variable on the left hand side. That is, only one variable is used on the left hand side, that is left of the equals to. That is legal, whereas this is not legal. In addition to the division operator, C also provides a modular division operator. This operator returns a remainder on dividing one integer with the another. Therefore, the expression that is 10 divided by 2 yields the 5, whereas 10 modulus 2. So these are the two expressions. One is the 10 divided by 2, that is simple dividing. One is 10 modulus 2, that gives the remainder. What is the remainder? That is 0. Note that the modulus operator cannot be applied on a float. This is most important part, that the modulus operator is only applied on the integer value, not applied on the float value. Also note that on using the modulus operator, the sign of the remainder is always same as the sign of the numerator. That is, minus 5 gives the minus 1, whereas 5 divided by minus 2 yields the 1. Next point says, careful point says, arithmetic instruction is often used for storing the character constant in character variable. This is used, that is often used for storing the character constant. First of all, these are defined, then give the character constant. This is when we do this, the ASCII value. Every character has a ASCII value. Then the ASCII value will be used in the variable. That is, ASCII value are used to represent any character in the memory. The ASCII value F and G are 70 and the 71. Then next point says, arithmetic operations can be performed on the int, float, and the char. Therefore, the statement that is char, int, x, y, z that is used are perfectly valid since the addition is performed on the ASCII value and not on the characters. Why they are correct? Because the operation or the addition is performed on the ASCII values, not on the characters. The ASCII value of A and B are the 97 and the 98. Next one says, no operator is assumed to be present. It must be written explicitly. In the following example, the multiplication operator after B must be explicitly written. Unlike other high-level languages, there is no operator for performing the operations. That is, no operator is used for performing the operations. Therefore, the following statements are invalid. These are the statements that is the invalid statement. These are the invalid statements because there is no operator for performing the exponential. If we want to do the exponential, we get it done with this way. This is the way to use the exponential. Exponential is what? That is in power of something, that is using the power function, that is POW function. Here power function is a standard library function. It is being used to raise the 3 to the power of 2. That is, first of all 3, that is 3, raise 3 to the power of 2. That is 2 power 3. That is, one header file is used, that is the hash include mat.h is a preprocessor directive or the preprocessor directive. It is used to ensure that the power function works correctly. That is, this is the standard file that contains the library function. One of the library function is a power function that is used, or that is that contains a standard library function, that is a power function. So this is a header file that must be included whenever we use the library functions like power function. This says it is being used to ensure that the power function works correctly. We would learn more about standard library function in chapter 5. Now, next is how to convert the integer and the float. That is the integer and the float conversions. This point says, in order to effectively develop C programs, it will be necessary to understand the rules that are used for the implicit conversion of the floating point and the integer value. That is, it must be, or it is mandatory to convert the integer point as well as the floating points. That is mentioned, arithmetic operation between the integer and the integer always yields an integer result. It means if I perform the integer operation or the integer operation between the integer values, arithmetic operation between the integer values and the integer values, that always gives the integer result. And the operation that can be done between the real and the real, that can also give the real result, that is a decimal result, float result. But if the operation performed between the integer and the real always yields a real result. Why? Because the decimal point, that is a float value, contains more bytes in memory. Integer is first promoted to a real and then the operation is performed. Hence the result is real. I think a few practical examples shown in the figure would put the issues beyond doubt. That is, it puts the issues beyond the doubt. That is, it is issued to beyond the doubt that how it will be used or how it will be used and how it will not be used. That is the next content, that is the next part that will be used. real values can give the result. So these are the different scenarios that can be used. That is how different scenario can be used. So this is the operation. First of all, this says 5 divided by 2, that both are the integer values. The result is 2. The operation is 2 divided by 5, that gives the 0. Then next is your 5.02, that gives the real values. Then 2.0 divided by 5, that gives the 0.4. In the same way, this one, that is, one is the integer value, one is the real value. So one is integer, that is a integer constant, one is your real constant, that is a floating point number. Next, type conversion in assignment, that is how we can convert, or how different conversions can be assigned or can be used, can be converted in the assignment operator. It may so happen that the type of expression and the type of variable on the left hand side can be used, or may not be same. In such case, the value of the expression is promoted or demoted depending on the type of variable. This is the, for example, this is this one. For example, consider the following expression, that is int I float b, int I equals to 35. That is, I is the integer type, but the value that is assigned is the 3.5, and the b is the float type. The value that is assigned is the 30. And in the first assignment, though the expression value is float 3.5, it cannot be stored in the I. That is, it is a I that gives a integer value, but this value is 3.5. Since it is an integer value, that it cannot store in I because it is an integer value, and integer takes only 2 bytes, but float takes 4 bytes. So it's not possible to store the 4 byte value in the 2 bytes value. In such a case, the float is demoted, that is, float is demoted to a int, that is, float is used as a int, and then its value is stored. Hence, what gets stored in I is 3, that is, what is stored in I is only 3. Because float is not possible, then 3.5, that is 0.5 is automatically gone, and only the value that is covered or that is stored is the 3 values. Then exactly opposite happen in the next statement. Here 30 is promoted to the 30.000 and stored in the B. Since B being a float variable cannot hold anything except the float values. Instead of simple example, use the complex expression. This is a complex expression. These are the arithmetic instruction. This is the result, that is 2 divided by 9 gives the 0. 2.0, that is divided by 9 gives a 0. Then 2 divided by 9.0, that is also a 0. This is gives the 4. Why 4? Because when 9 divided by 2, then the quotient is 4. Then 9.0 divided by 2, then the question is also 4. 9 divided by 2.0, then the question or the result is also 4. In the same way, when we divide two integer or two real constant, that is 9.0 and the 2.0, that is also gives the output 4. In the same way, 2 divided by 9, that is a 0. 2.0 divided by 9, that is 0.222. Note that the following statement gives the result 0 and the result obtained differently. In the first statement, 2 and 9 are the integers. The result is 0. This 0 is assigned to the k. In the second statement, 9 is promoted to the 9.0. Then the division is performed. Divide yields 0.22. So this is the example, 0.22. Now, this is the most important part, that is hierarchy of operations or operators. That is, what is the hierarchy? How these different operations can be performed. That is the hierarchy of operation. That is the levels of operations. This says, while executing an arithmetic statement, that is, while we execute an arithmetic statement which has 2 or more operators, you may have some problems as to how exactly does it get executed. That is how it will be executed. That is a problem. For example, does the expression 2 into x minus 3 into y correspond to 2x minus 3y? That is it. If the expression is this one, that is 2 into x minus 3 into y, then the expression it also possible to the 2x minus 3y or to the 2x minus 3y. Simply does a divided by b into c correspond to a divided by b into c. That is, this comes in the bracket, then whole is multiplied and then divided by the or divisible by the a, which must correspond to this one or this one. Either we can put over here in the bracket or either we can put this into the bracket. To answer these questions satisfactorily, one had to understand the hierarchy of operation. That is, either we use the multiplication first, either we use the division first. So what is the meaning? What is the hierarchy, or how is that be possible? This priority or precedence in which the operations in an arithmetic statement are performed is known as the hierarchy of operation. That is, either use divide first or either use multiply first. It depends on the hierarchy. If the divide comes prior in the hierarchy, then use the divide first. The hierarchy of common used operators is shown in the figure 1.8. This is the first priority, that is used multiplication, division and the modulus operator. That is the first priority that is used. Either use the multiplication operator, either use the division operator, or either use the modulus operator, that is the modular operator. Then next priority is that plus and the minus, that is the addition and the subtraction. These are the two priorities that can be used. Next, third priority is your assignment, that is your equals to, that is the assignment operator. Then there are few tips that is about the usage of the operators in general. Within the parenthesis with the same hierarchy, that is, if that same hierarchy level, that is the plus and the minus, is available in the parenthesis, is available in the bracket as mentioned in the 1.11. Also, if there are more than one set of parentheses, then the operation within the inner parenthesis will be performed first, followed by the operation within the second innermost pair and the so on. This is a hierarchy, that is, first of all inner parenthesis bracket will be solved, then outer, then most outer, that is the next parenthesis can be solved. We must always remember to use the pairs of parentheses, that is, we use the pairs of parentheses. A careful imbalance of the right and the left parenthesis is a common error. That is, either we use the left or the right parenthesis, that is also the common error. Best way to avoid this error is to type parenthesis and then type an expression inside it. That is, either we use the left, either we use the right. A few examples. Determine the hierarchy of operations and evaluate the following expression. Now, this is the most important part, that is how to organize the different operators into different hierarchy and how to solve them. So this says determining the hierarchy of operations and evaluates the following expression. This is I equals to 2 into 3 divided by 4 plus 4 divided by 4 plus 8 minus 2 plus 5 divided by 8. This is the stepwise evaluation of this expression is shown below. This is the stepwise execution, that is 2 divided by 3 divided by 4 plus 4, 4 plus 8, 2 plus 5 divided by 8. Now, first of all, there is a hierarchy. First of all, there is a multiplication, then division, then modulus. So first of all, multiplication can also be applied. So first of all, multiplication is done. That is, this will be done. Only this will be done. That is 6 divided by 4 plus 4 divided by 5. Sorry, 4 plus 8 minus 2 plus 5 minus 8. The same output, only multiplication is performed. Then next priorities are multiplication, that all the multiplication value can be used. Then modulus operator, but in this example there is no modulus operator. So use the multiplication and the division first. So first of all, multiply can be done. Then next is your division operator, that is divide the value or use the division operator. First of all, this can be divided, that is 6 divided by 4, that is a 1, plus 4 divided by 4. That is, first of all, only this one will be performed, that is divide operation can be performed, that is 6 divided by 4. Then next divide operator will be used, that is 4 divided by 4. Now this is 1, this is same, 8 minus 2 plus 5 divided by 8. Then next this operation will be performed, that is whenever we divide the smallest number with the largest number, that gives the output 0. So this is 0, this is 1 plus 1 plus 8 minus 2 plus 0. Now next priority is your addition and subtraction. Now there is addition that is available, so first of all perform the addition operation, that is 1 plus 1 is 2 plus 8 minus 2 plus 0 as it is. Then again perform the plus operator, that is 2 plus 8, that is 10 minus 2 plus 0. Then next there is no, there is also addition, this is also addition that is used, that is 2 plus 0 is, first of all there is a minus operator that is used, that is 10 minus 2 plus 0. This means this comes from the left to the right, then gives the plus operator because they have the similar precedence. Either we use the addition, either we use the subtraction. This is the most important point, that is at the same level we use the left to the right expression, that is we come forward from the left to the right, that is first of all this one, this one, this one, if the same operator or the same precedence operator is used. Note that 6 by 4 gives the 1 and not 1.5. Why? Because it is an integer value and it is an integer constant. This so happens because 6 and 4 both are the integer and therefore it's only integer constant. In the same way, this gives to 0 because 5 and 8 are integer and they must read in an integer value. Now next approach or the next part, that is maintain the hierarchy, that is determine the hierarchy of the operation, that is how these expressions, how these operators is used, and then solve the following expression. So same concept, first of all the first value is multiplication, division, modulus operator, then addition, subtraction, then next precedence is your assignment operator, right? And if there are at the same level, there are different expressions, there are different same type of precedence operator, then go or comes from the left to the right. This is first of all there is a division, multiplication, division, plus. So at the first level there is a division operator as well as the multiplication operator as well as the modular operator. But in this there is no modular operator, only the division as well as the multiplication is used. So comes from the left, that is 3 divided by 2, that is first of all division will be used. When we divide 3 by 2, that gives the output 1, that is multiplied by 4, then plus 3 divided by 8 plus 3, that is as it is. Then use the multiplication, use the multiplication operator, because multiplication and division are same, and in the left hand side there is first of all multiply, then 4 divided by 4 into 1 is 4 plus 3 divided by 8 plus 3. Then next there is a plus operator, but the plus operator precedence has a low as comparison to the divide operator. So 4 plus 3 is not possible, but then this is also possible, that gives the output 0. Then use the addition operator from the left side, that is 4 plus 0 is 4 plus 3, then at last and add the number, that is 4 plus 3. So it means if I am talking about the precedence, there are different operators, there are different precedence, and if there are at the same level there are different operators that is of the same precedence, so use the left to the right margin, that is left to the right process. Note that 3 plus 8 gives the 0, again for the same reason mentioned in the previous example. All operators in C are ranked according to their precedence, and mind you are there 45 odd operators in C. These can affect the evaluation. Unfortunately, there are no simple rules that is used such as board mass that tell the algebra in which way the expression will be used for the evaluation. We have not encountered many of these 45 operators. So we won't pursue the subject of precedence any further here. However, it can be realized at this stage that it would be almost impossible to remember the precedence of all these operators. So full-fledged list of operators and their precedence is provided in the appendix A, that is at the end of the session. Now, what is the associativity of the operator? There are two types, one is left to right and right to left. Left to right means that the left operand must be unambiguous, that is unambiguous in what sense? It must not be involved in evaluation of any sub-expression. Similarly, in the case of right to left, the right operator or operand must be unambiguous. That is, there is a tie between the operators of the same priority between this one and this one, the same. The tie is settled using the associativity of the multiply and the divide, but both enjoy left to the right associativity. That is, first of all this will be performed, then output is multiplied by the 5. Left operand is ambiguous, right is not. Right operand is unambiguous, left is not. In this there is an assignment operator that is used. Both the assignment operator has the same priority at the same level, that is right to the left, that is used for the each operator. This is the equals to sign, that is the assignment operator. Then at the left margin there is a equals to, at the right margin there is a b, that is b equals to 3. Now consider the next expression, that is the next part. Here there is a z that is used, a into b plus c divided by c. Here multiply and divide enjoy same priority and the same associativity. That is, at the same line there are different operators that have a same precedence as well as the different operators that have a same associativity. Figure 1.12 shows for each operator which operand is unambiguous and which is not. Here both the operators are unambiguous. Here, since left operands for both operators are unambiguous, compiler is free to perform multiply or divide operation as per its convenience. Since no matter which is performed earlier, the result will be same. Now the next part, that is your control instructions. Till now we have discussed type, declaration statements, instructions, arithmetic instructions. Now next is your important part, that is your control instructions in C. That is, what are the control instructions that is available in the C language. This says, as the name suggests, the control instruction that enables you to specify the order in which various instructions in a programs are executed by the programmer. That is, it gives the order in which various instructions in the programs are to be executed by the computer. That is, if there are multiple instructions, which instruction can be used or executed by the computer. In other words, it determines, that is, a control instruction determines the flow of control. That is, how program will be flowed from one part to the another part. That is the flow of control in a program. There are 4 types of control instructions, that is sequence control instruction, selection or decision control instruction, repetition or loop control instruction, case control instruction. So these are the 4 instructions that defines the flow of program in the C, and these are the most important instructions, and these 4 include sequence control, selection or decision, repetition or loop, case control instruction. The sequence control instruction ensures that the instructions are executed in the same order in which they appear in the program. Decision and control instruction, that means the sequence ensures that the instructions are executed in a sequence in which they appear in the program. In the same way, decision and case control instructions allows the computer to take a decision as to which instruction is to be executed next. That is, decision is taken, that is which instruction is to be executed next, that is done by the decision and the case control instructions. The loop control instruction helps the computer to execute a group of statements repeatedly. So first of all, sequence that maintains the sequence, decision that is used for maintaining the decision, that is used for making the decisions, then repetition or loop that is used for the repetition purpose, that is if the one program is or the if one variable is used in the repetitive way, that is a repetition or the loop control instruction. The loop control instructions helps the computer to execute a group of statements repeatedly. In the following chapter, we are going to learn these instructions in detail. Try to hand at the exercise presented on the following pages before proceed to the next chapter. So these are the few instructions that is available for the control statements. Now this is the summary of the chapter. That is, three primary constant and variable types in C are the integer, float and the character. A variable name can be of maximum 31 character. Do not use a keyword as a variable name. An expression may contain the sequence of instructions. Operators have a equal precedence as evaluated using associativity, that is from left to the right. Input and output can be achieved by using the scanf and the printf. So these are the various questions. These are the various quizzes that is available. Now let's see one or two quiz. Pick up the correct alternative for each of the following questions. C language has been developed by Ken Thompson, Dennis Ritchie, Peter Norton, Martin Richard. Please tell me the answer with the help of the chat. Yeah, Larry. What about you? What is or who developed the C language? Can you answer with the help of the chat? Basically C was developed or C has been developed by the Dennis Ritchie. That is the second option. Then C can be used on MS-DOS, Linux, Windows. Means it can be used either on the MS-DOS, either on the Linux, either on the Windows, or all of the above. That is, it is used on the all of the above statement. So the answer is all of the above. Then C programs are converted into machine level language with the help of, that is, what is the tool that is used to convert the C language into the machine language, that is a 0-1 language. Which tool is used, which application is used, that is a Larry, tell me the answer of C. You answer the second C, that is a 2. Yeah, you are correct. That is C programs are converted by using the compiler. The real constant in C can be expressed in which of the following form? That is, if I'm using the real constant, that is a fractional part, how it can be expressed in the terms of the following forms? Either in fraction form, exponential form, ASCII form, or the both exponential and the fractional. That is, the decimal form can be represented by using which expression, by using which form? The answer is fractional form only. Why? Because they are using, or it is using, the decimal point number. Next point says a variable, character variable can at times store how many characters? 1 character, 8 character, 254, none of the above. That is a 1 character. Yes, your answer is correct. Then the statement char cs equal to z would store in the ch. That is, what is stored? It stores the ASCII value. It stores the character z along with the commas, both 1 and the 2. Answer is your ASCII value. As I told you, whenever any capital character is stored to the variable having the ch or the char as a ch, then use the ASCII value of that character. Then next point says, or next question says, which of the following is not a character constant? That is, which is not a character constant? Either this one, this one, this one, this one. That is not a character constant. The answer is all of the above. Why? Because this is also a string. That is not a character constant. This is also a string. This is also a string. Right? Then next point says the maximum value or integer can have this one, this one, this one, this one. Remember, I told you that this is the maximum length that can be used, and this is the minimum length, that is from this to this one. So this is the maximum length that can be used, that is 32767. All other questions you can see. If you have any doubts, then please ask from me. I'm going to start with your new chapter, that is the second chapter, that is a decision control structures. As I told you, there are different control structure. One is decision, one is sequence. So next chapter is your, second chapter is your decision control structures, that is how decision will be taken. But before this, let's take 5 minutes break, only breather break, because there is no time today. I will finish the class as soon as possible. So let's take only 5 minutes break. Please come back sharp at the after the 5 minutes, then start with this chapter, that is a decision control structures. So let's take break for 5 minutes. Next part or next chapter contains the decision control structure. Now let's start with the next chapter, that is the second chapter. What are the decision control structure that is available? Now what is a decisions? This chapter contains what is a decision, what is the if statement, what is the real thing, how multiple statements are used within the if, how to use the if else statement, how to use the nested if else, that is if else, that is within the if else there are multiple if else. Then forms of if, use of the logical operators, the if else or else if condition, ampersand operator, that is the explanation operator, that is the not operator, hierarchy of the operators, word of caution, or the conditional operators. This says we all need to alter our action in the face of changing circumstances. If the weather is fine, then I will go for a stroll. If the highway is busy, I will make a diversion. That is, at every condition, at every time, we'll make a decision. That is, if it is raining outside, and then I will take the umbrella. If it is not raining, then I will not take the umbrella. I would look elsewhere. If you like this book, I would write the next edition. That is, if the book is suitable as per your notes, then I would write the next edition, that is the next edition of the book. You can notice that all these decisions depends on the some condition being met. That is, these decisions can be based on the conditions. What is the condition? If it is raining outside, I will bring the, or I will take the, or I have took the umbrella. So these are the various decisions that is available in the C language also, and these decisions are taken or take care of the programming language which comes under the decision control structures or decision control statements. This says C language too must be able to perform different set of actions depending on the circumstances. In fact, this is what makes it a sort. There are three decisions that is used. One is only the if, one is if else statement, one is the switch statement. That is, one is only the if statement, if else statement, and the switch statement. A fourth less important structure is the one that uses the conditional operator. So three, that is the basic. One is if, one is if else, one is the switch statement. And the next, that is a less important structure that uses the conditional operator. That is, use the conditional operator. There are multiple conditional operator. In this chapter we will explore all these way, that is except the switch, which has a separate chapter devoted to it in a later stage, in which a C program can react to the changing circumstances. Then decisions. What is mean by decision? In the program written in chapter 1, we have used the sequence control structure in which various steps are executed sequentially. That is, various steps are used sequentially, various methods are used in a sequence way. That is, in the same order in which they appear in the program. That is, it is maintained in the sequence. In fact, to execute these instructions or instructions sequentially, we don't have to do anything at all. By default, instructions are executed sequentially. However, in serious programming situations, we need to take the decisions. Many a time, we want our set of instruction to be executed in one situation. That is, entirely different set of instruction to be executed in other situation. This kind of situation is dealt in the C program using a decision control instruction. That is, there are some scenarios, there are some condition in which decisions can be taken on the basis of the programming. There is no sequential flow, there is no sequential statement. There are some conditions, there are some scenarios in which C programs is using the conditions that is known as the decision control instructions. As mentioned earlier, a decision control instruction can be implemented in C using if statement, if else statement, and the conditional operator. So there are three kinds of decision control statement. One is the if, one is the if else, and one is the conditional operator. So these three are the decision control instructions. Now let us learn each of these and their variation in turn. Now let us discuss if else, and the switch statement, or the last one is your conditional operators. Now first of all, what is the if statement? Like most languages, C uses the keyword if to implement the decision control instruction. That is, like most languages, or for the most languages, C uses the keyword. C uses one of the word that is a keyword, that is a main word, that is the if, to implement the decision control structure. What is the general form? What is the syntax for the if statement? This is the syntax of the if statement. That is, if condition is true, then only execute this statement. That is, if the condition is true, then only the statement will be executed. Like for example, if 2 is greater than 3, then print the value hello, otherwise, no, there is no otherwise till now. That is, if the 2 is greater than 3, then executes or print the value or print the output as a hello. The keyword if tells a compiler that what follows is a decision control structure. That is, this follows, or this gives the output, or this gives the condition that the compiler that this is a decision that is based on the C language, that is a decision control instruction. Next point says the following condition following the keyword if is always enclosed within a pair of parentheses. That is, this is enclosed in a parenthesis. This is a parenthesis. This is a parenthesis. If the condition, whatever it is, it's true, then the statement is executed. If the condition is not true, then the statement is not executed. That this condition is checked, that the condition is checked. If the condition is true, then only statement will be executed, otherwise statement is not executed. Instead, the following step or the program skips past it. But how do we express the condition itself in the C? And how do we evaluate its truth or falsity? That is how we can evaluate this is the correct or the not. The relational operators allow us to compare two values to see whether they are equal or unequal, whether one is greater than the other or not. This is the statement that is used here, how they look and how they are evaluated in the C. That is, if I am using double equals to, that is, check the equality sign. If x is equals to the 2, that is x is equal to y. Then not equals to, this is a sign of the not equals to, that is x is not equals to the y. Then x is less than y, x is greater than y, x is less than or equals to the y, that is the less than or equals to operator. This is the condition, this is the expression that shows that x is, or check the condition whether x is less than or equals to y, this is greater than or equals to y. This says the relational operator should be familiar to you except the equality operator. This is the equality operator. Note, there are two types of operator. One is equality operator, one is a assignment operator. Equality operator is using the double equals to, that is 2 times equals to. But single equals to is used for the assignment operator, that is a equals to 10, that is 10 value is assigned to the a. So there are two types, one is single equals to, one is double equals to. Double equals to is used for the double equals to is used for the checking the equality sign or checking the equality, and single equal is used for the assignment operator. And the inequality operator, that is an explanation mark equals to. Note that equals to is used for the assignment, that is used for the assignment, and this is used for the comparison. As I told you, one is single equals to, one is double equal to. So single equals to is used for the assignment and double equals to is used for the comparison. Here is a simple example which demonstrates of the use of the if and the relational operators. This is the example. Now first of all, main function is used, that is the main function. Then curly braces start, then there is a one variable that is declared, that is a num variable, int num, that is of integer type. Then use the statement, that is a printf enter number less than 10, that is enter any number that is or that must be less than 10. Then scanf, use the scanf, use the percentage d, use the percentage d. Next, this is a statement, that is a main statement. Then there is a declaration of the variable, that is int num. Then uses the printf, that is used for printing, that is enter a number less than the 10, that is entering number that is less than the 10 value. Then scanf, that means taking the input, that is a scanf, use the percentage d. Why it is using the percentage d? Because it is using the integer value, that is a ampersand num. Then if the num is less than or equals to 10, then check the condition. This is the main part, that is check the condition, that if the num, that is a variable that is given by the user, variable value, num value, if that value is less than or equals to, maybe it is less than, that is either 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 as well as the 10. That is, if it is less than or equals to 10, then printf, what's an obedient servant you are. So this is the condition, this is the program that shows how if condition will be used. So if it is a condition that is used, or that is used for the checking the condition and displays the output based on the condition. This says on execution of this program, if you are typing a number less than or equals to the 10, that is either you use the 10 or less than 10, then you get a message on the screen, that is the through the printf. If it is greater than 10, that is 11, 12 or beyond that 10, then it does not give any output. If you type some other number, that is except from 1 to 10, if you type another number, the program does not do anything. The following flowchart will help you the flow of the program. So this is the flowchart. This is the new concept for you. Please understand, this is a flowchart that describes the flow of the control, how flow will be maintained. Then there is a start button, or there is a start option that is available. Then this can be used by using the oval shape. Then use the parallelogram option, that is a print enter a number that is less than 10. That is print the number that is enter a number, or print the same line, that is enter a number that is less than 10. That is either use 0, 1, 2, 3, 4 till 10. Then next, input the num, that is input or take the input from the user, that is a num. Then use if it is num is greater than 10, then check the condition. If num is greater than 10, then print what is an obedient on servant you are. If it is no, then there is a stop value. To make you comfortable, so this means this is a diamond box that is used for checking the condition. One is yes, one is no. If it is yes, then print what's an obedient person you are, servant you are. If it is no, then use the stop value. To make you comfortable with the decision control instruction, one more example has been used or given below. So this is the next example that is used, that is while purchasing certain item, the discount of 10% offered if the quantity purchased is more than 1000. That is, if the quantity is more than or greater than 1000, then the discount is 10%. And if the quantity and the price per item are input through the keyboard, write a program to calculate the total expenses. This is the program that is used to calculate the total expenses. And what is the input that is taken? One is quantity, one is price. This is the example that uses start then discount equals to 0, that is take the discount equals to 0, or initializing the variable, that is discount equals to 0, then input the values, input the variables as the quantity and the rate, that is take the input variable or take the variable as a quantity and the rate, then checks the condition. Checks the condition that if the quantity is greater than 1000, that is if the quantity is greater than 1000, then provides a discount that is equals to 10. If it is no, that is less than 1000, then calculate the value, that is total equals to quantity into rate minus quantity into rate into discount divided by 100. Then print TOT, that is print the value, that is a TOT, and then at last stop the values. So this is the flow chart that shows if the percentage count or if it is used is more than 1000, then uses or provides a discount as a 10, otherwise do not provide any discount. And then providing the discount, that is if you providing the discount, then use the formula, that is quantity into rate minus quantity into rate into discount divided by 100. Then print the values, that is print TOT, that is your total value. So this is the example, this is a program that shows how discount will be calculated. That is using the variable, that is calculation of the total expenses. First of all, main function will be used, then use quantity discount equals to 0. That is initializing the values, initializing the variables to the 0. That is quantity discount equals to the 0. Then use the float, that is rate TOT. Then uses the two variable, that is a float type, that is rate, as well as the TOT, that is your total. So two variables are of integer type, that is quantity and the discount, and two are of float type, that is a rate and the total. Now then use the printf, that is enter quantity and the rate, that is this will be printed, that enter the quantity and the rate. Then scanf, that is scanning the values, uses the %d %f. Why %d %f? Because quantity is in the integer and the rate is in the float. So use the %d and the %f, that is quantity and the rate. Now this is the important part, that is check the condition. What is the condition? If the quantity is greater than 1000, that the quantity that is used is greater than 1000, then gives the discount that is equals to the 10. That is if the quantity is greater than 1000, then give the discount as a 10. That is the next part that is used. Then calculate the total, that is calculates the total value. What is the total value? That is quantity into rate minus quantity into rate into discount divided by 100. That is uses the next value, that is uses the total function. Then printf the value, that is total discount equals to the next value. That is uses the condition, that is total discount equals to the next value. This is the example that is used for the interaction purpose. That is what is the enter the quantity, enter the rate. First of all, quantity will be entered, then rate will be entered. The quantity that is entered is the 1200 and the rate that will be entered is the 15.50. So one quantity, one rate will be entered. Then uses the total expenses, that is the total expenses that is used, that is quantity into rate minus quantity into rate multiplied by discount divided by 100. Then next point says enter the quantity and the rate. This is the example, that is enter the quantity as well as enter the rate. In the first run of the program, the condition evaluates to true. But why the condition is true? Because the rate is or the quantity is 1200, as 1200 value of quantity is greater than 1000. As I told you, that if the quantity is greater than 1000, then check or then give the discount to the 10. Otherwise, it does not give the discount. Therefore, the variable discount which were earlier set to 0 now gets a new value, that is a 10. So this is the example that shows how quantity will be used. In the second run, the condition evaluates to false. That is, if it is 0, that is, if it is 200, then does not give any result. That is, does not give any discount. That is the next part. That is less than the 1000. The real thing is that we mentioned that the general form is this one. Truly speaking, the general form is this one. That is, this is the expression, not the condition. That is, if expression, then statement. That is, if the expression is followed, then statement will be executed. Here the expression can be any valid expression including a relational expression. That is, it can be any expression including the relational operator including the next operator that can be used. We can even use the arithmetic expressions in the if statement. For example, the following if statements are valid. This is also valid if 3 plus 2 divided by 5. This works. This is also works. This also works. Now, next is multiple statements within the if. That is how to use the multiple statement within the if. That is how to use multiple if within the if. That is, one if is considered within another if. It may so happen that in a program we want more than one statement to be executed if the expression following if is satisfied. If such multiple statements are to be executed, then they must be placed within a pair of braces as illustrated in the example. Now this is the example for calculating the bonus. These are the various variables that is used: bonus, CY, year of joining, year of service. This is the printf line that is used for only entering the data, that is used for storing the input value that is given by the user in the memory. That is %d, %d, CY, YOJ. That is year of joining. Then year of service equals to CY minus YOJ. That is calculate the year of service, that is current joining, current year minus year of joining. That is the year of service which I am taken. That is the current year, that is the today's year or the this year, and minus by the year of joining. Then if the year of joining is greater than 3, that is if it greater than 3, then gives the bonus as 2500, printf the bonus, what is the bonus. So the condition is that if the year of service, that is current year minus year of joining, is greater than 3, then gives the bonus as a 2500 and at last prints the bonus. This is the flowchart that shows how bonus will be applied. First of all, getting the start, that is done by the start button. Then input the current year as well as the year of joining. That what is the current year and what is the year of joining. Then calculate the year of service by calculating the current year minus year of joining. Then check the condition. If the year of service is greater than 3, that if it is greater than 3, then the person is getting the services or it is in the service prior to the 3 years or greater than 3 years. If it is yes, then gives the bonus as a 2500, print the bonus. Otherwise no, then stop over here only. Now next is your if-else statement. That is how to use the if-else statement. That I will discuss in the next class. That's all for today's session. Thank you so much everyone. Thank you so much everyone for listening me carefully. In the tomorrow's class, I am going to start with your topic, that is the if-else statement. So that's all for today's session. Thank you so much everyone.